Section 7.3, Simplifying Complex Rational Expressions. When you hear the word rational expressions, you should think fractions. Now, when students see the word complex, a lot of times they think that means difficult. Well, what that means in this section is that you're just going to have multiple fractions over multiple fractions. So that's what makes it complex. So, a complex rational expression is when you're dividing a fraction or fractions by another fraction or fractions. So you're going to see lots of fractions in this section. We have two methods to solve. Method 1 is when you have one fraction over one fraction. The steps would be to change division to multiplication, then flip the second fraction, that's the one in the denominator, and then use multiplication rules. So again, we use method 1 when we have one fraction over one fraction. Method 2 comes into play when we have multiple fractions over multiple fractions. Well, the first step would be to multiply the numerator and the denominator by the LCD for all fractions. Second step, combine like terms. Third step, factor if possible. So if you see any plus signs or minus signs, we try and factor. And lastly, cancel if any like factors appear on top and bottom. Again, you can actually make method 2 into method 1 if you don't ever want to use method 2. All you would have to do is make the multiple fractions into a single fraction by finding a least common denominator and combining them. So if you don't like method 2, you can certainly use method 1 every single time. But I'm going to show both ways. So looking at number 1, the direction says simplify. 5/9 divided by 7/12. That falls under the category of method 1. We have one fraction over one fraction. So using the steps listed, we're going to change division to multiplication. So 5/9 division becomes multiplication, and we're going to flip 7/12. And so the flip would be 12 over 7. That's the reciprocal. Now that we're multiplying, we don't need to find common denominator. We can just multiply straight across or cross cancel. When I multiply straight across, 5 times 12 is 60. All over 9 times 7 is 63. And then we need to see if we can reduce that. 60 over 63 can be reduced by 3 each. So 60 divided by 3 is 20, and 63 divided by 3 is 21. So I get 20 over 21 as my final answer. If you wanted to cross cancel at the very beginning, when we had 5/9 times 12 over 7, you could have canceled a 3 here and a 3 there, so that would have been a 4 on top. So 5 times 4 is 20, and 3 times 7 is 21. So either multiply straight across and then reduce, or cross cancel as you go. Looking at number 2, we have 1/6 minus 1/3 all over 1/4 minus 1/8. Definitely falls under method 2. Why? Because we have multiple fractions over multiple fractions. So let's see if we can follow these steps. Multiply the numerator and the denominator by the LCD for all fractions. So first of all, my denominators are 6, 3, 4, and 8. What's the first number 6, 3, 4, and 8 can all go into? Is 24. So my LCD is 24. So what will I do with that? I'll multiply the whole numerator by 24. And the whole denominator by 24. And remember, it's 24 over 1, so you're just multiplying by 24 over 24, a fun kind of 1. So we'll distribute the 24 across. 24 times 1 is 24, but divided by 6 is 4. 24 times 1 is 24, but divided by 3 is 8. In the denominator, 24 times 1 is 24, but divided by 4 is 6. And 24 times 1 is 24, but divided by 8 is 3. So we end up with 4 minus 8 all over 6 minus 3, which gives us a negative 4 over 3. And that's how we use method 2. So number 3, 1 over x plus 2 over y all over 2 over x plus 1 over y. We see that we have multiple fractions over multiple fractions, so we need to find our LCD. So our denominators are x and y, and another x and a y. So my LCD has to be x times y. So what will I do? I'll multiply the whole numerator by xy and the whole denominator by xy. Again, it's over 1, so you multiply by the numerator and then reduce. When I multiply xy times 1, but divide by x, I end up with a y. Plus, when I multiply xy times 2, but divide by y, I end up with the 2x. Over, When I multiply xy times 2 but divide by x, I get 2y. And xy times 1 but divided by y is just going to be plus x. So I do see I have plus signs on top and bottom, so I try and factor. Y plus 2x cannot be factored, and 2y plus x cannot be factored. So there's no canceling involved, therefore I'm done with my problem. My final answer is y plus 2x all over 2y plus x. Number 4. 2x divided by 3x cubed minus 3x all over 4x divided by 6x minus 6. Looking at this, we have to decide, is this method 1 or is this method 2? It actually is just method 1 because you have one fraction over one fraction. Here's my numerator fraction and here's my denominator fraction. So it is just one fraction over one fraction. So using the rules for method 1, I'll change division to multiplication and flip my second fraction. So 2x over 3x cubed minus 3x, division becomes multiplication, and I'll flip the second fraction. So if I flip it, I get 6x minus 6 on top all over 4x. Now that I have multiplication, I can draw one long line. I don't need to find a common denominator, but I do need to start trying to factor. Well, 2x cannot be factored, so I'll leave that as is. In the denominator, 3x cubed minus 3x, I could factor out a 3x. When I factor out a 3x, I'm left with x squared minus 1. That can be factored farther, but I'll wait. Another numerator was 6x minus 6, so I'll take out a 6 and I'm left with x minus 1. And the other denominator, 4x, will leave us 4x. So let's go ahead and factor x squared minus 1. That factors into x plus 1 times x minus 1, so that's gone. So at this point, let's start canceling any like factors that appear on top and bottom. I have an x minus 1 on top and an x minus 1 on bottom. Remember, this is 2 times x and 3 times x and 4 times x. So those are not stuck together, so I can cancel that x with whatever x I want. So I'll cancel that x on top with the first x in the denominator. So what do I have? So far on top I have 2 times 6, which is 12, all over. In the denominator, 3 times 4, which is 12. I still have that x, and I still have the x plus 1. Now I see there's a 12 on top and bottom, so I'll cancel the 12 on top and bottom, leaving me with a 1 on top, all over x times x plus 1. If you want to distribute in the x, you can, but you don't have to. Number 5, 1 minus a to the negative 1, all over 1 minus a to the negative 2. That looks a little bit different. Why does that look a little bit different? Because of the fact that we have a negative exponent. So, what do we need to do with that? Well, I would rewrite a to the negative 1 as 1 over a, and a to the negative 2 as 1 over a squared. But be careful, you can't bring it all the way down to a denominator because it's attached to the 1. So what I mean by that is we have 1 minus 1 over a. A to the negative 1 is really 1 over a. Divided by 1 minus a to the negative 2 is 1 over a squared. Back with our exponent rules, we realize negative exponents don't make anything negative. They move things from top to bottom or bottom to top, depending on where it's negative. Since we have a to the negative 2 on top, it needs to go to denominator and become positive. So now we need to find which method we use, method 1 or method 2. This would be method 2. We have multiple fractions over multiple fractions, so we need to find our LCD. So looking at our denominators, we have an a and an a squared. So our LCD would be a squared. So I'll need to multiply the whole numerator by an a squared and the whole denominator by an a squared. Again, they're over 1, so when we multiply, then we get to reduce. So a squared times 1 is a squared. A squared times 1, but divided by a, is just a. A squared times 1 is a squared, and a squared times 1, but divided by a squared, is 1. So we get a squared minus 1 in the denominator. Now we look to see if we can factor because we have subtraction. A squared minus a, we can take out an a, and we're left with a minus 1. And the denominator, a squared minus 1, would factor into a plus 1 times a minus 1. So now we look to see if there's any like term on top and bottom. We see an a minus 1 on top and bottom. So our final answer would be a over a plus 1. So number 6. 4 minus 1 over x squared all over 4 plus 4 over x plus 1 over x squared. Definitely method 2 because we see multiple fractions over multiple fractions. So let's find the LCD. Well, looking at our denominators, we have an x squared, an x, and an x squared. So the LCD will be x squared. Multiply the whole numerator by x squared, again over 1, and the whole denominator by x squared over 1. If you want to put the x squared at the front, you can. I just put it at the back. Wherever you like to is fine. Distributing in the x squared, 4 times x squared is just 4x squared. 4x squared times 1 but divided by x squared is 1. And the denominator, x squared times 4 is 4x squared. X squared times 4 but divided by x would be plus 4x. And x squared times 1 but divided by x squared would be plus 1. So now we need to factor. 4x squared minus 1 on top is your difference of squares. That's going to factor into 2x plus 1 times 2x minus 1. And the denominator, 4x squared plus 4x plus 1, that's the AC method. So that takes a little bit longer. I'm going to jump to the factors. You fill in the AC method. Look back at some of our previous videos to help with that. And that's going to factor into 2x plus 1 times 2x plus 1. Now we look to see if we have any like factors on top and bottom, and we do, so the 2x plus 1's cancel, and I'm left with 2x minus 1 all over 2x plus 1. Nothing else can cancel, so therefore we're done. Lastly, number 7, 1 plus 1 over x minus 2 all over 1 minus 1 over x minus 2. Again, multiple fractions over multiple fractions, so we'll need to find our LCD. Well, our only denominator is x minus 2. So I'll multiply the first by x minus 2, and the denominator as well by x minus 2. Again, it's over 1, so when we multiply, hopefully some things will cancel. When I multiply x minus 2 times 1, I just get x minus 2 times 1, plus, when I multiply x minus 2 times 1 but divide by x minus 2, I just get a plus 1. And the denominator, x minus 2 times 1 is just 1 times x minus 2, minus, when I multiply x minus 2 times 1 but divide by x minus 2, I just get a 1. Distributing your 1 doesn't really change anything, so I just get an x minus 2 plus 1. And the denominator, distributing the 1, again I just get an x minus 2 minus 1. Combining like terms, we get an x minus 1 all over x minus 3. Those cannot be factored, so therefore nothing cancels, and that's my final answer, x minus 1 over x minus 3.